Okay, so we started chapter 11, that is sequences. So I'll just recall what we did yesterday. So what is a sequence? Sequence is a list of numbers. So it's like a list of numbers. And we say a sequence is convergent if we take the limit of the sequence, the n term that is in the sequence, we take an n term. This is called the n term. And if you take the limit when n approaches to infinity, your n term will give you a number, like a finite number. We say the sequence is sequence. This is a finite number. We call finite number. Then we say sequence is convergent. Okay, so we did monotonic sequences, increasing sequences. So let's first see, I will recall what is monotonic sequence again, but let's start with this today. So let's see what is the meaning of if we say the sequence is bounded. What is the meaning of that? Okay, so this is the norm. Okay, so if we say the sequence that the n term a sub n is less than or equal to a particular number, this is like a some value. If you see something like that, if the n term is less than some value, then we say the sequence is bounded above. Or also we say it has a upper bound. It's bounded by number. So if the n term has some value, it is less than or equal to some value, then we say that the sequence is bounded above. And if we draw this, like let's visualize this one. So let's say your sequence is like this. This is an increase in sequence. Increase in sequence. And this sequence it doesn't go beyond this line. This line is M. This discrete value, this points doesn't go beyond this number. Okay. So it never goes above the line. Then we say the sequence is bounded. Is bounded. So without writing the whole term bounded, in future I will just write it as BDD, which is just bounded. So bounded, the sequence is bounded above. And that is M. And then let's see what about if the sequence will look like this. If the sequence, the n term, let's see if you have something like this. That is the n term of a sequence is greater than or equal to some number. This is some number, some value. So this means if you come across something like this means the sequence is bounded below. Okay, so if you come across something like this, then we say the sequence is bounded below. So let's visualize this one. Bounded below. So if you have a decreasing, this is a decreasing sequence. Decreasing sequence. And this never goes. So this is the line. This is the line N. If this decreasing sequence never goes below N, then we say the sequence is bounded below. Bounded below. Or it has a lower bound. Okay. What if it has a upper bound and a lower bound both? Then what sequence is called? So the next type is if your sequence will look like this now. This type is has a upper bound or and lower bound, both. Then we say the sequence is bounded. Okay, so if you have lower bound and upper bound both, then we can say the sequence is bounded. Sequence is bounded. Or else we can say it's a bounded sequence. So let's visualize this one. So let's see if you have something like this. Your sequence will look like this now. But it has upper bound, that is M. And also it has a lower bound, that is N. So if you have lower bound and upper bound, then we can say, by looking at the graph, we can say this is a bounded sequence. Okay. Now let's write like a theorem. Note. Note. If the sequence is bounded, so will the upper bound and the lower bound. There's a question. Let's see. So will the upper bound and the lower bounds only have the monotonic sequence and the bounded sequence? Yeah, I'm going to talk about it now, like after this one. Okay. So so let's say if the sequence is bounded, So that means bounded means sequence has a upper limit, I mean upper bound and a lower bound. Okay, where it is bounded above and bounded below, and also it is monotonic. So here, if these two conditions are satisfied, that means if the sequence is bounded, that means it has a upper bound and a lower bound. And also it is monotonic. What is monotonic? Monotonic means, can you remember the sequence can be either increasing sequence or the sequence can be either decreasing sequence. If both conditions are satisfied, that is monotonic and bounded, then we can say the sequence, the whole sequence is convergent. Then the sequence is convergent. Convergent. So I will write this as like a short note. So if you have AN, so AN is, A sub n is the n term of a sequence. If this sequence is bounded and also it is monotonic, then AN, that is A sub, converges. Sequence converges. That's the idea. Okay, so let's do an example to understand this part. So the first one example, your n term is 1 over n squared. So can you, so we need to check whether this is monotonic. That means we have to check, how to check whether it is an increasing sequence or a decreasing sequence. So this can be how to check that if it is increasing or decreasing. We can either do it by a graphically. Okay, so we can either graph this sequence and check whether it is decreasing or increasing. Okay, or else we can write the first terms and look. So let's do some of the like ways that you can check whether it is increasing or decreasing. So first, can you write the first 4 terms of the sequence? Mallory, yes, it's if we write, yes, good. Yes, I see correct answer. 1 over 4, 1 over 9, and 1 over 16. Okay, then what can we say about, is it an increasing sequence or a decreasing sequence? It is a decreasing. Okay, so we can say this is a decreasing monotonic sequence. Monotonic sequence. Okay, or else, so this is just one way, just writing the terms and check whether it is monotonic sequence or not. Or else we can check by drawing a graph. Draw the graph. Let's say this as a function, 1 over x squared. So you will have this graph will look like this. So it is always decreasing. Okay, so it's always decreasing. What is another way from college algebra? Because I'm giving different ways because some questions will be easy if you draw the graph, or some question will be easy what we showed yesterday. I will recall that also. But the third one is also we can take the so if you have this is so I mentioned that sequence n term is look like a function. So you can check the first derivative of the function. What is the first derivative of this? 1 of x squared. What is the first derivative? Check it again, William. What is the first derivative of 1 of x squared? Yes, girl. So it is negative 2 x to the power negative 3. Okay, so if we say when x is greater than 0, if the first derivative is we get negative values, then we can say, so if this is negative, so your function fx is decreasing. So these are the two things. These are the two things to check if the function is decreasing. Okay, now let's see what we learned yesterday for sequence. How do we check whether it is increasing or decreasing? Since we from here we know it is decreasing. To prove in mathematically, we have to show that the n term is greater than equal to the a sub n plus 1. So if we how did we check this? We check this if this is a true statement, we just substitute the values. So this is another way to show the sequence is decreasing. Now we need to show that this is true. So how to do that? Just substitute your nth term. Your nth term is 1 over n squared. Can you all do? Can you just substitute and check whether it is a true statement or not? True. Kyla says true. Others? True. Yeah, true. So let's see how to solve that. We need to check this whether this is a true statement. So substitute. So a sub n, the n term is 1 over n squared greater than equal to n plus 1 squared. Okay. Multiply multiply both sides by n plus 1 squared, so that we can get cancelled this one. And then we have in the left hand side n1 plus squared, n squared greater than equal to 1. Then we can multiply by n squared both sides. So you have, so this get cancelled, n plus 1 squared greater than n squared. Okay, by then FOIL we have in the left hand side n squared 2n plus 1 greater than equal to n squared. So since this is, you have the same term, then we have in the right hand side, it's just 0 because when you deduct n squared, so you have 2n plus 1 greater than or equal to 0. We mentioned, so to be a sequence, always n should be a positive integer, right? So if n is equal to positive integer, that means if n is equal to 1, then what is this form? So 2 plus 1 is 3, 3 is greater than 0. This is a true state, right? If n is equal to 2, what happened? 7 is greater than 0. This is true state. So we get a true statement. So this is a true statement. So then we can say, thus, we can say a sub n is greater than a sub n plus 1. Then we can say by looking at this sequence is a decreasing sequence. Decreasing sequence, and we can say this is monotonic. Okay, so we showed that the sequence is decreasing, always decreasing. So we can say this sequence is monotonic. Is monotonic. Okay, so we showed that the sequence is monotonic. Then what is the other part we have to show? That we have to show that this sequence is bounded. Okay, so if we show this sequence is bounded, then we can say that this whole sequence, the sequence is convergent. Okay, so how to check the boundedness? So bounded, now we need to check the boundedness. So we can draw, we draw the graph right before. So when we draw the graph, so our sequence was 1 over 4, 1 over 9, like that. So you will get something like this. Okay, so we can find a bounded, so we can find, so here this is 1. You see this sequence, any term, it doesn't go beyond 1, right? So we can say this 1 is the, m is equal to 1 is the upper bound. Okay, and also this sequence doesn't go beyond 0 because we saw it's getting very small. We get very small numbers, but it doesn't go beyond 0. So then we can say the lower bound, we can get a 0. So this means your sequence that is bounded above by 1 and bounded below by 0. So we can say it is between 0 and 1. This is your enter. So this is this sequence. because we satisfy this condition, yes. Just a second. Okay, there was umbrella, yes. Okay. Okay, sorry. Because this is, so we can say, yes, the sequence is bounded. Okay, so we show the sequence is bounded, and monotonic. Monotonic means this is a decreasing monotonic sequence. Then we can say the sequence is, therefore, the sequence is convergent. Therefore, the sequence is convergent. Okay, so this is another way to show the convergence of a sequence. So if you can check whether it is monotonic, and if you prove that this sequence is bounded, then we can say the sequence is convergent. So what does it mean by convergence of a sequence? So this means if n approaches to n term of the sequence is, you get a finite number. This is the idea. Convergent means that. Convergent of a sequence. Okay. Does it always have to have an upper and upper and lower bound and still fit this idea? No, so to be a convergent sequence, it has to be bounded. So what does it mean, Len? Bounded mean it should have the upper bound and lower bound. So there is a question in the chat box. Does it always have to have an upper and a lower bound and still fit this idea, or can it have one bound? If there is only one bound, that means it is not bounded, okay? So we cannot. This is not true. Okay, to be a convergent sequence, it should be bounded. So bounded means upper and lower bound. Both should be satisfied. And then the sequence should be monotonic. Okay, any questions other than this? Okay, so you can start doing 11.1 homework questions. I think I have to change the due date. I think I have fixed it for today or tomorrow. I will change the due date for that. But if for those who came login late, I send all the test grades. So if you if you think you got a lower mark or anything like that, you can do the corrections and send me your paper via an email, so I can give you some partial credit. Okay. Okay, so do your corrections. Okay, so let's start series. So this chapter 11 is very important. So the next one is also important. But are you all okay with sequences now? Everyone? Okay, so practice questions, then you will be fine. So let's start the next important one, that is series. Okay, so we wrote a sequence the sequence notation is this. Okay, curly bracket. It's here, or we can also write it like this. Sequence has the notation of this. But if you take the sum of all these the terms in the sequence, so let's say if you write like this, if we add the terms of an infinite sequence. So that means we add all the terms in the sequence. So first, in the last section, we did only the sequence. We did only n term of a sequence. Here, if we add all the terms in the sequence, then we can say, then we get, so if we add all the terms, it represents like this. The first term, we add the second term, third term, we add all the terms, n term, we add all the terms. And this is called infinite series. Infinite series, or also we can call series. Okay, so what is the idea? We add all the terms in the sequence. So if we add all the terms in the sequence, then we can say this is a infinite series. Remember here we have infinite sequence. Okay, so if we add all the numbers, we have infinite series. So then we write the notation of infinite series. We write it like this. So this is called the summation. That means you add all the terms. So here it is from n is equal to 1 to infinity. You add all the terms. Or else you can also write just the summation known and a sub n. So this is the notation of infinite series. Okay. So after this, so from this section onwards, we are going to learn different kind of methods to check whether this series is convergent or divergent. Okay, so that's the idea we are going to learn. So from here, what we are going to learn is we need to know whether the series is convergent or divergent. That's what we are going to learn. So let's do an example. Example, infinite series or series of 2n. Okay, so this is an infinite series. We need to know whether is this a convergent series or a divergent series. Convergent or divergent series. Okay, so let's first, again, let's check what is the difference of the sequence and a series. So difference of, this is not the answer for this question, but here we are learning how to solve this. Okay, so difference of sequence and series. Okay, so the sequence when we mention the sequence, we always took the end term, right? This is the end term. So what is the end term of this one? This is 2n. Okay, then if we write the sequence, what are the four terms? I mean, what are the terms? Can you tell me what are the first four terms of the sequence? What are the four terms of the sequence? 1, 2, 6, 8. Yes. Is it 1? Is 1 included? What is it? It should be 2, right? The first term should be 2 because always n should be positive integers. So when n is equal to 1 here, 2 multiplied by 1 is just 2. So 2, 4, 6, 8. This goes around. So this is a sequence. Now, when we are considering the convergent and divergent of the series, to check it, we need a thing called S sub n. So this is called the partial sum. Partial sum. So as an example, this means, so S sub 1 means when n is equal to 1, what is our first term? That is 2. It's just 2. Okay. And S sub 2 means the partial sum when n is equal to 2. So this means you add the first term and the second term. That's 2 plus 4 is 6. Okay, so this idea is partial sum of first two terms. So like that, can you find what is S sub 3 and what is S sub 4? 12, 20. So it is 12 and 20. Okay. Okay, so this will go beyond. So, but here we are taking just a partial sum. So, okay, so we can write now. We can write a sequence of partial sums. So these are the partial sums. S sub 1, S sub 2, S sub 3. These are the partial sums. We can write a sequence of partial sums. So that is 2, 6, 12, 20. So this is a sequence of partial sum. If this sequence, now let's see what is the convergent and divergent. If this sequence, that is the sequence of partial sum, goes to infinity, then we say series is divergent. Okay, so if the sequence, it stops, so I'll write it here. So if this denoted by S infinity, so this means 2, 6, 12, 20. This is just going, will just go forever. So then we say this means this is called infinite series. Infinite series. So, but if called infinite, and it is a divergent infinite series. So if the partial sums, if you add if the partial sum is convergent, I will write again, if this sequence goes to a finite number, then we say it is a convergent series. So how to write this in terms of like mathematically? So if you have this term 2n, we write this as limit when n goes to infinity s sub n. Okay, so let's do this. So let's do this question again. So okay, okay. So now how to prove this? So this is our question. Now let's see how to prove this. So the first step is determine the partial sum Sn. So for that we need to know the type of the sequence. The sequence that you are dealing around. So this sequence, so we have the sequence AN is 2, 4, 6, 8, and this goes on. What type of a sequence is this? What is the type of? Can you remember what is the type of this sequence? So it is monotonic. So just forget about this monotonic and this part. It is increasing. Yes, it is increasing. So it is a monotonic sequence. But this type, if you maybe you have learned in high school or not, if you have, so here you see the difference always, difference of these two numbers is 2, right? If the difference of these two numbers is 2, if the difference of these two numbers is 2, if you have the same difference, this sequence we call it as arithmetic sequence. So the idea is you add the same number or common difference. Okay, so if you get a arithmetic sequence, then the partial sum of the sequence is the first term and the last term divided by 2 multiplied by n. So this, if you don't remember this is, you have to remember. If it is a arithmetic sequence, that means if it has a common difference like this sequence, this is the partial sum of the arithmetic sequence. Have you ever seen about this arithmetic sequence? Have you done this, any of you? Geometric series, anything? Okay, okay. So I see most of you, most of you doesn't know. So whenever if you have a sequence like this, if let's say this is our sequence 2, 4, 6, 8, 10, like that. So to identify the whether it is an arithmetic sequence or not, you take the difference of two terms. Okay, if the difference of two terms are equal, so here the difference of 4 and 6, it's just 2. Difference of 6 and 8, it's just 2. Difference of 8 and 10, it's always 2. This is called arithmetic sequence. Okay, if you have the terms and if you take the difference of the terms, these are called arithmetic sequence. Then the partial sum of the arithmetic sequence is this formula. Okay, you don't need to know like the proof of how do we get the partial sum. So just remember, this is the partial sum of the arithmetic sequence. I will give you this, like in the exam, I will give you these formulas. So this is the partial sum of a arithmetic sequence. So let's see what is the term, what is the idea. So this means this is a partial sum. So this means this is the first term of the sequence. First term of the sequence. And here this is the last end term of the end term of the sequence. Okay. Okay, so what we need to know whether the series is a convergent or divergent, we have to check to show the convergence of a series. We need to show that when n approaches to infinity, this partial sum, the limit of this partial sum goes to a number, which is, this is a finite number. This is finite. Okay, if you get infinity, then it is not a convergence series. So let's see whether this example is convergence or not. Okay, so just can you find what is the equation of the partial sum? So just substitute the first term. What is the first term of this sequence? It's just 2. What is the n term? That is 2n. Just substitute and just tell me what is the, just give a expression by cancelling and all. let's go slowly because it's kind of it's a new topic. Okay, so I see some answers. So just substitute for this equation. This is n plus n squared. Okay. Okay, so let's do. So the first term, so this is what we are going to use. So the n partial term. So the first term is 2. And the second n term is 2n. Divide by 2. And then you will get 2 is common. So 2 get cancelled here. 2 is common for all the terms. So you will get 1 plus n. Okay. So this is your partial sum of n terms. Okay. So now we need to check the limit. When n approaches to infinity, what happened to your partial sum? Can you tell me what happened to your partial sum? When n approaches to infinity, our partial sum also, yes, your partial sum approaches to infinity. So this means, yes, it's infinity. So this means this is like 1 plus infinity multiply infinity, right? So infinity means it's like a very large number multiplied by another large number. So you get a larger number. Okay, so it means it's infinity. So that's the idea. So this is whole thing goes to infinity. So this means your partial sum is a very large number. So we can say if you get the partial sum as infinity, then we can say, your series, then the series is it a power of n? No? It's times n, because here it is 1 plus n times n. This is n. This is times n, okay? This whole thing multiplied by n. That's the idea.
Whenever you wrote the formula, it's times n as well.
Oh, it's sorry, this is this whole term multiplied by n.
Okay, I had a power.
Others, did you all also thought it's like a power? No, it's multiplied by n. Okay. Okay. So this is okay. So our partial sum is now infinity. It's not a finite number. Then we say the infinite series. Then we say our infinite series. So this is infinite series. So this is equal to, how do we write? We can write infinite series also by this limit when n approaches to infinity, the partial sum. This is called a partial sum. This we get in infinity. Okay, so then we say the series is divergence. divergent. Okay, so let's again recall what we did. So recall, this is a sequence and this is a series. To check the convergence, up to here, I will teach you other ways, but up to here, how did we find whether a sequence is convergent? So your sequence will look like this, okay, curly bracket. Your series is something like this. Summation, infinity goes to a sub n. So if a sequence is convergent, we need to show that if n approaches to infinity, limit of this n term. N term, this is just a finite number. Finite number. Okay. Then what we learned today, the series is a convergence if we show, so our series is this. To show the series is convergent, we show limit n approaches to infinity. The partial sum goes to an, just let's say a number, a different number, maybe like L, no, M or something like that, just a number. It's just a number, finite number. So this is partial sum. So if we show the partial sum when n approaches to infinity, we can say it is finite number, then we can say the series is convergent. This is the idea. This is what we did up to here. Okay, so to find so the idea of the series, to check, and Sn is this, yes, very good, Kyla. It's a good question. So here in this example, we did the partial sum of only a arithmetic sequence. Okay, partial sum of arithmetic sequence. There will be different kind of sequences and there will be different kind of partial sums of equations. This Sn, it is different to question to question. Like an, remember a sub n was also different, like all the terms is different. It's the same thing to series also. So to check the convergence, first thing is you have to find the sum. Partial sum. So sum means S. That means you have to check whether this is this sum goes to infinity or not. So if the sum is infinity, like in this question, series diverges. If the sum is finite, then the series converges. I just wrote in words what I mentioned here. Okay, so Okay, so this is one way of showing whether the series is convergent or divergent. The next important one is divergence test. So divergent test is another way to check whether the series is divergent. Okay, remember, let's write the definition, then I will explain. So the divergence test means if we have a sequence, let's say AN, okay, if limit, if n approaches to infinity, AN, this is like the what we did in the previous one. If a n term of a sequence, okay, because we mentioned it's a sequence. If the limit goes when n approaches to infinity, the n term of this is not equal to 0. Okay, remember it's not equal to 0. Then we can say then the series is diverges. So this is very easy. So to check whether a series is diverges, we can just show the limit of an n term. This is the n term of a sequence is not equal. We'll do an example. It's not equal to 0. It's divergent. But remember, don't forget, let's say if limit n approaches to infinity, a sub n is equal to 0, then what do you think? Then what do you think? The series is convergent or divergent? So we think the series is convergent because it's the opposite of divergent, but it doesn't work like that. Okay, so that's the important part of divergent test. Remember thoroughly, in the divergent test, only the idea we can get is only this. If the limit of a sequence is not equal to 0, we can say the series is divergent. But if the limit of the sequence is 0, it can be divergent or convergent. Then the series can be divergent or convergent. So if the limit of the sequence is 0, we have to do another way of technique to find whether the series of convergent or divergence. Okay, remember this, it's very important. Divergent test is very important. So if it is not equal to only 0, we can say the series is divergent. Okay, so let's do an example. So the same example, can you find the same example we did now? Use now divergence test. Okay, so what is the n term? What is the n term here? It's just 2n. Okay, it's just 2n. This is n term. So to check whether it is divergent, I mean whether it is to use the divergence test, we need to take the limit when n approaches to infinity, your n term. So what happened to your n term there? This is equal to infinity, right? So this is not equal to 0 because it's infinity. Therefore, thus limit when n approaches infinity, your n term is not equal to 0. Then straight away we can say the series is diverges. Okay, so your n term was 2n. 2n is divergent. So it's easy, right? The divergent test, this one is easy comparing to the previous method we did. Okay, then the same thing, can you find the series, infinite series of 5n plus 3 divided by 7n minus 4. Is it convergent or divergent? So use the divergence test. It can be either convergent or divergent. Okay, let's see. So Jai, you got the limit as 0. You got the limit as 0. What? Okay, it's okay. So what is the end of? So what the first step? 5/7. Yes, Emma converges. It converges. Okay, I see some of you again did some mistakes. Okay, how to do this one? So the first step is you have to identify the end term. What is the end term here? Let's do with me. What is the end term? What is the n? Okay, yes, good. 5n plus 3 over 7n minus 4. Okay, okay. Okay, so then what we have to check? We need to check when n approaches to infinity, what happened to your n term? Okay, so when n approaches to infinity, 5n plus 3 over 7n minus 4. So yesterday I did a method. Remember, whenever you have, so there is a n here, you know already when n approaches to infinity, 1 over n is equal to 0, right? So what can we do? We can divide all the terms here by n, so that we can get something like this. So 5n divided by n plus 3 divided by n, 7n divided by n, 4 divided by n. Now this is limits, okay? This is not convergence or divergence. This is limit knowledge. So whenever you divide by n, all the terms, this get cancelled, this get cancelled. So you will have limit n approaches to infinity, pi plus 3 over n minus 7 minus 4 over n. Okay, so this means, so we can say when n approaches to infinity, this whole thing goes to 0 by using this theorem. If n goes to infinity, this whole thing goes to 0. So you will have 5 over 7. Okay. Now is this 0? No, this is not 0. So limit n approaches to infinity, 5n plus 3 over 7 minus 4 is not equal to 0. Okay, then what can we say? By the divergence test, then by divergence test, this limit is not equal to 0. Then by the divergence test, what happens? The series diverges. Okay, so then by the divergence test, the series 5n plus 3 or 7 minus 4 diverges. Okay. Any questions here? Why do you, I see some of you did mistakes. Let's see. Mallory, are you okay now? Jai, okay? Okay, others? William, others, everyone? Micah? Okay, let's do another example because I see some of the students will have, because this divergent test is very important. We'll do another examples. I will give it by. Okay, what about this? It's the same idea, same idea. So if the limit is then the series. So the Emma asked the question. Let's see. So we have a question. So if the limit is 0, then the series is that's why I said if so. The only thing that we can get from the divergent test is if the limit is not equal to 0, it diverges. The series diverges. If the limit is equal to If the limit is equal to 0, we cannot say whether it is divergence or convergence. Okay, it's we have to use a different technique. You cannot, I mean, you can use the divergence theorem, but we cannot say exactly whether it is divergent or convergent. Okay, so we have to use another technique. I will teach different kind of techniques, but that's the idea. Okay, can you use the same idea? Let's see now whether you can understand. Can you check whether this series is convergent or divergent? So just show this. Yeah, this is. Can you check? Divergent. Okay. William says it's divergent. Others? Divergent. Okay, Brady. Kami. Okay, now I see correct answers. So this one also same thing like before. The first step here is by the limit. So this is your n term. So n term, we have to check the limit of the n term. So limit of the n term is n squared, 5n squared plus 4. Okay, we can divide all the terms by the highest degree of the nth variable. So we can divide all the terms by n squared because that's the highest degree of n. So then you have limit when n approaches to infinity. This is 1, this is 5, this is 4 over n squared. So when the limit n goes to infinity, this whole thing becomes 0. So you will have 1 over 5, which is not equal to 0. Okay, so then we can say the series, our series is 5n squared plus 4 diverges. Okay, okay, so and so why did we use this divergence test instead of taking partial sum? Because sometimes in the previous question we did in the partial sum, we know the equation of the partial sum. Okay, because we identify that sequence is an arithmetic sequence. So we were able to find the limit of the partial sum. Okay. Okay, then, but here we use divergence theorem because sometimes some sequences we cannot find the partial sum. We don't know what is the equation of the partial sum. So that's why we use the divergence theorem here. Okay, so now let's see another kind of series. This is called geometric series. Example. Now we are going to learn the how to find it's another kind of series, geometric series. So for that, let's do some I'll write some notes. So first, let's see what is the form of a geometric series. What is the form of a geometric series? So geometric series, you will have, if you see a series like this, A multiplied by R to the power n minus 1. So this means if I write it in summation, so when n is equal to 1, n minus 1 is 0, R to the power 0, it's just 1. So it's just the first term is A. Then the second term, when this is when n is equal to 1. Then the second term, when n is equal to 2, we get A. It's a constant for all the terms, A. It doesn't change. Only the R term changes, R to the power 1. Okay. Then what is the third term? Can you tell me what is the third term? AR squared. Okay, so like that, the next term is ARQ. So this will just go. Okay. Okay, so this R is called the common ratio. We call it common ratio. Okay. So our goal is now in this kind of series, our goal is identify R. That is the common ratio. Why? Let's say why it is because if the absolute value of R is less than 1, then series convergent. Okay, so whenever you find, if you find the R value is less than 1, then we can straight away say the series convergent. When R is, absolute value of R is greater than or equal to 1, then series is divergent. So now here you will see in geometric series, depend on the common ratio, we can say either it is convergent or divergence. But from in the previous one, in the divergence theory, divergent test, we can only say whether the series is divergent. We cannot say whether it is convergent or the other way around. Okay, so let's do an example for this. And also, if you have, because the series is convergent, when the R is equal to 1, then the sum, remember the partial sum or the sum, the whole sum of this part, S is equal to, we can straight away write an equation A sub 1 minus 1 minus R if absolute value is less than 1. Okay, so this idea means A sub 1 is the first term of the sequence. And R is the common ratio. So if we identify the common ratio is less than 1, we can straight away use this formula to find the sum of the series, because series means the sum. So we can find just using this formula, we can find the sum. So let's do an example, then you will understand. But this is the idea. So let's say you have the series as 8 plus 4 plus 2 plus 1 half. Okay. Because it's under geometric series, it's geometric series. But what is the first term of this series? Eight. Okay, so the first term is 8. Now we need to know what is the common ratio, that is R. How to find the common ratio? R is, you can just use the 0.5. Yes. Yes, good, Micah. So R is how to find the common ratio. You can divide A2 by A1. Okay, so the second term, what is the second term? It's just 4. 4 divided by the first term is half or 0.5. Or else you can choose anyone. What about this term? This is the third term. This is the second term. This is the first term. You can also check A3 divided by A2. What is A3 divided by A2? What is the third term and what is the second term? It's the same thing, right? 2 over 4, it's just half. Okay. Also, you can check more whether it is we can check whether it is a geometric series. A4 divided by A3. What is this value? Same thing, half. So you see, we get a common ratio. Okay, between two numbers, we get a common ratio. So this is called the common ratio. Why it is named as a common ratio? Because we take a ratio of two numbers. Okay, so we get a common ratio. So since we get a common ratio, and this is absolute value R, but this is anyway, it's a positive number. Half is less than 1 or greater than 1, definitely less than 1, right? So then what can we say about the series? Convergent. Okay, because R is less than 1, then we can say the series is convergent. Is convergent. Okay, because the series is convergent, then convergent means when you take the sum, you will get a finite number, not an infinite number. Okay, so then what is the sum? What is the sum? Is means the sum of the series. So this is same as, this sum means same as your infinite series, your infinite series, but here it is not given, but sum is infinite series here. So what is the sum here? Yes, okay, so the sum formula is the first term divided by 1 minus the common ratio. Okay, so the first term is 8 divided by 1 minus R is of common ratio, that's half. So it is 8 divided by half, it is 16. So this is your sum of the series. So you see, it's a convergent, right? It's a 16 is convergent. It's like a finite number. Okay, so that's why we say the series convergent. Okay, so can you try this question? Example 2, 2, and 3, 1 minus n. Is it convergence or divergence? Micah, can you mute your? What is the geometric series equation? Geometric series is if you identify your series will look like this. A r to the power n minus 1, then we can say it's a geometric series. This is kind of like a exam type question, so maybe you might get this in your finals or test too. So let's see whether we can change this to this one. Okay. Kyla, it's divergent forward 3. Yes, yeah, very good. I see. Yes, Kyla, good, very good. Others, do you want to try? Okay, so let's see how to do this. So here you see there's n, there's 1 minus n. We need n minus 1, something like that. Okay, so how to get n minus 1? We can change. We can first write this is 2 to the power 2n. That is same as 2 to the power 2n, right? By exponent knowledge. And this is 3 to the power 1 minus n. So this means this we can write 2 to the power 2 is 4 to the power n. Okay. This one, because we need n minus 1, we can take the negative exponent, right? Can you remember whenever you had a to the power negative m, we can write it as 1 over a to the power m. So same thing, I'm going to write this term. I'm going to put it into the denominator. So 3, now the sign of the exponent changes. Now negative n becomes positive n. Plus 1 becomes negative 1. Okay. Okay. So then what? Then here we can write also, because still we are not closer to here, but somewhat we are close, because in the denominator we have n minus 1. Then we can say 4 to the power n, we can write it as 4 multiplied by 4 to the power n minus 1, right? Because it's the same base, we can add the exponent. If you add the exponent, you get n. Okay, and this is 3 to the power n minus 1. Okay, now this we can write it like 4 over 3 to the power n minus 1. Okay. Okay. So then what is A here? And what is R? What is A here? 4. Yes, Lee. R is 4 over 3, right? So R is 4 over 3. Okay, so R is 4 over 3. Is it less than 1 or greater than 1? It's greater than 1, right? It's greater than 1. So then what can we say about the series? It's divergent, okay? Because in the R is greater than 1, thus the series diverges. Okay, so we cannot find a sum because its series diverges. That means it's just going to infinity whenever whenever this next term is divided by, whenever you have a common ratio, it is diverges. Okay. Okay, so this is one type of technique that we can use, geometric series, to find whether the series is convergent or divergent. Okay, so that's that. So quiz 5, your new quiz is quiz 5. Try this one. Infinity and plus 1, 2 to the power 3n, 5 to the power 1 minus 2n. Check whether this is convergence or divergence. Convergent or divergent. Okay. So I'm going to do another type, but I'm not going to prove this type. This is called, is it 2 times 5 or minus 5? 2 times. 2 times. This is 2 times. Okay, Mal. Just let me know if my handwriting is not clear, because when I'm writing with this pen in the iPad, sometimes it's not clear. Okay, so next type is, so we today we learn arithmetic means, arithmetic series. So arithmetic series is if you have a series something like this. If the first term is A, the second term is 1 plus D. Then the third term is 1 plus 2D. So this sequence is arithmetic sequence. So the common difference you will see it's D. And also we learn geometric series. That is, the first term is A, then the second term is you multiply by R. Third term AR square, AR cube. Like this is we call geometric series. Arithmetic series sequence and geometric series. And another type of series is harmonic series. You will see this harmonic series if you if you do other math courses or in other type of engineering courses, this harmonic series. So harmonic series has the form of this 1 over n. It's always 1 over n. The sum of 1 over. So this means 1 plus half plus 1 over 3. 1 over 4. This goes on. Okay, this is always divergent. This is divergent. So the proof of this is in the book. Proof is in the book. So if you like to read, if you want to get more knowledge about it, you can read the proof of the harmonic series. So whenever come across something like this, like whenever you have to sum 1 over nth, that's a harmonic series and it's always divergent. Okay. Next type is we call telescopic series. So I'll just explain what it is. So this will look like this. I will explain it by an example. So if you come across a series like this, 1 over n plus 1, 1 over n plus 2. Now you need to check whether it is convergence or divergence. Okay. So, so the to check the convergence or divergence, remember in the beginning of the class, we took the partial sum of the we took the partial sum and we took when n approaches infinity, what happened to the partial sum. Okay, so if it is get a finite number, we say it is convergent. If it is infinity, we say it is divergent. Okay, so can you check when n is equal to 1 and when n is equal to 2? Okay, so I'll just write this. So whenever you write it, so when n is equal to 1, this will look like this. That is 1 over 2 minus 1 over 3. Okay, so I'm going to write this as a sum because it's the series. I take all the sum plus. So this is the first term, that is a1 when n is equal to 1. Then the second term is when n is equal to 2. So that is you will get 1 over 3 minus 1 over 4. So this is your second term when n is equal to 2. Then your third term, you will get 1 over 4 minus 1 over 5. Third term when n is equal to 5. So this will keep on going. And let's say when n is equal to n minus 1, n plus 1, this is when n is equal to, this is a sub n minus 1. Then the n term will look like n plus 1, n plus 2. Okay. Okay, so this will just keep on. So this is your an term. Okay, so can you see a pattern of this? What happened to the, what happened in this series? So here you see it is half minus 1 over 3. And again you add 1 over 3. So you see this get cancelled, right? Negative 1 over 3 plus 1 over 3 get cancelled. What about this term? Here you will see you have 1 over 4, negative 1 over 4. This get cancelled to here. Okay, all the middle terms, it getting cancelled. So here again in the n minus 1 term and n, you see this will get cancelled. Okay, so your partial sum Sn, you will get the first term, that is first term is half. This is there, it didn't cancel. And the last term is there, that is 1 over n plus 2. Okay, so this is your partial sum. Now you can just check the limit when n approaches to infinity. What happens this? What is the value of this one? What is the value? When n approaches to infinity, yes, it's half, right? Because half, it's a constant. Limit of a constant is this constant minus limit when n approaches to infinity, 1 over n plus 2. So it's the same as this when n approaches infinity, 1 over n is 0. It's same as that. So this is 1 half minus 0. This whole thing is 0 because the denominator is a very large number. So you will get half. So what we showed is we showed the partial sum is half. So this means this is a finite number, right? So then what can we say about the series? We showed the partial sum is a finite number. Then what can we say about the series? Convergent. So the series, yes, guys, very good. 1 over n plus 2. This is converges. Okay. The series is convergent. So this type we call as telescopic series. What happens here? Whenever you take the partial sum, you take the first term and the last term. First term minus the last term. It depends, it will differ in questions, but the idea is always the middle terms get cancelled. Okay, so always these middle terms get cancelled. Only the first term and the last term will be there. Okay, so this is called the telescopic series, and we can find the partial sum, and then we can use this idea. We have to check whether the limit n approaches to infinity, the partial sum is finite number or infinity. If it is finite number, like this question, it is converges, the series converges. Otherwise, the series is diverges. Okay? Okay. So that's all for today. I won't take you much. I know it's a lot, but yeah. So this is series. Try to do, I think I might do some few examples tomorrow, but we have ended 11.2 also. So you can start doing chapter 11.2 also, homework from. No, it's not. It can be. So the Lexi asked whether it is always convergence or divergence. It can be convergence or divergence. You have to find this one, limit of the partial sum, like we did before. We have to check the limit of the partial sum is finite or infinity. If it is finite only, it is convergence. Okay. Okay, that's all for today. See you tomorrow. If you have any questions, you can say. I see some students ask some questions. Let's see.
I want to ask if we can see what we got wrong on the exam.
Just this was I didn't see who asked the question.
Me,
Mika?
Mika.
Mika, I think Mika, didn't I send you your paper yesterday?
Let me check.
Just check your emails because I sent I sent all, but I'm not sure whether you got it. If you didn't get it, just let me know. I will check the papers and find your paper and send you. Okay. Okay, so what else?
Also, when is the quiz due?
Can I the other one? Can you go back over what you said about? Okay, the test corrections. So let's say you got 80 for the test one. So if you do the corrections, I can give you partial credit, like some marks. So do the correction and send me send me an email. But please send me one PDF file. So I will give you partial credit for the exam. Okay, so if you get 80, you will get more than 80 after you do the corrections. Okay. The quiz, I'm not sure. I have to check. I think I changed the due dates for tomorrow or today. Oh, you mean the this quiz, right? I will give you the deadline for this quiz. What is the due date for the today's quiz? Okay. Yeah,
Thank you.
that's okay. What else? Others? The exam 2 will be on next. It's 20. It's a Monday. It will be on 24th. 24th. Okay, so okay, yeah. Exam 2 and 3. There is no exam 3. Instead, it will be the final exam, so it will be the same week. So Monday and Friday. Okay. Okay, William, you're welcome. Have you posted the class? Yes, Emma.
When is the 10.5 homework going to be due, since we didn't get notes for that yet?
Oh, no, 10.5 because we haven't done. It's not due. It's not due yet. Yes.
Okay, thank you.
Mhm.
Oh, that's what I meant. Like, I thought 10.5 was the class we missed Tuesday.
No, okay. Yes, I was thinking what did you mean by that? No, 10.5 we haven't done, so it's not due. You don't have to do the 10.5. Okay. Is
Also,
that
sorry,
all?
I know I asked. Oh, sorry.
No, this one. You
I know
can
I
say.
asked yesterday about the notes from like last Thursday to 10.3.
Yeah, I was
Yeah.
doing it's so much it has 140 pages. Maybe I'll
If you
take pictures.
if you just sorry. If you post the whole thing, I can go look through it to find them.
Yeah, I was going to do that. I was going to put the whole thing, but you know, when I use no what do you call good notes. So in the good notes, when I downloaded it, it's not it doesn't I mean, there's a problem. I will sort it and send you, but I definitely I tried today. But if it is not sorted, I will take pictures of Thursday class and post.
Okay, thank you so much. It was just
Okay.
because like the homework's due tonight and I just didn't have the notes, so yeah.
Oh, which part you want to know? 10.3 or?
10.3, yeah.
Yeah, then I will take pictures and post it today. Okay?
Okay, thank you so much.
Yeah.